Okay, so we're going to go ahead and get started. Looks like you've got your, you may want to take some notes here, because this is kind of involved. Okay, we're going to go over the lesson 11.2, events involving not and or. So our objectives are, knowing the probability of an event is real between 0 and 1 for both, knowing the meaning in terms of a possible event and a certain event, understand the correspondence among theory, logic, and arithmetic symbols, determine the probability of not an such as an event, given the probability of an event occurring, and determine the probability of event A or B, given the probabilities of A, B, and AB. All right, so let's see what all that means. Probabilities. Okay, so basically, we've looked at this before. The probability of an event occurring can be 0, which would be impossible, or to 1, which is certain. So an impossible event would be 0 probability. Well, why is that significant? Actually, that's pretty significant because, like if you were looking at something such as, let's say you're playing, let's say that you're in the desert, okay, and you're thinking, okay, the probability that you're going to get flooded today from a downpour and there's no prediction of rain is pretty unlikely. So that's either 0 or close to 0. Whereas the probability of a certain event is 1. That would be probability of rain, and it's raining. That would be 100%. Okay. All right. So let's take a look at some problems. When a single fair die is rolled, find the probability at each event the 3 is rolled. So here we have a fair dice, right? Okay, we got on a single dice. Just 1, right? Yeah. So that would be 1 over the total over 6. So our probability of rolling a 3 is 1 over 6. Okay? So the probability of not rolling a 3, something other than a 3, would be 1 minus the probability of rolling a 3. So this would be signified as not. So we said that the probability of rolling a 3 was 1 over 6. So this would be 1 minus 1 over 6. So we would change the 1 to get a common denominator, right? Minus 1 over 6. So all we did was change the 1 so that we get a common denominator. And so now our probability of not rolling a 3 is what? You go ahead and get off the cell phones, please. Appreciate it. So, what would be the probability of not rolling a 3? So that's 6 minus 1, right, is what? Well, here's our sample space. There's a number of 7s over the total. Since there's 0 7s, it's impossible to roll a 7 when it's not even in the sample space. Okay? With a single dice. With 2 dice you can, but not with a single dice. So the probability, a number less than 7. Well, if this, so basically number less than 7 is all of them, right? So basically that's all 6 of them. So numbers less than 7 over the total, there's 6 less than 7 over total is 6, so that's a probability of 1, right? And so that makes it certain that you're going to roll a number less than 7 on a single dice. Okay? Questions with that? All right. Okay, so that's all that. So on the next table, basically we're looking at different ways that we've expressed the complement and subtraction. Complement, for set theory, we used a little apostrophe. For addition, combining, we used the union. Intersection, for and, we used logic, we used the not symbol or tilde. Or was a V-looking symbol, and was rooftop-looking symbol or an upside-down V. And so arithmetic, and this is what we're using. In probability, we have subtraction. Okay, so in complement, we have not is probability of S, which is universal set, minus the event is our complement. So whatever's in, if we looked at our universal set and we looked at our event, the complement would be what is not inside the circle. So if we took the complement and the event, that adds up to 1. Okay? All right. When a single card is drawn from a standard deck, what is the probability that it will not be an ace? All right. So if we were to draw a card from a deck, let's say we drew a card from a deck, probably not being an ace, right? All right, so the way we do this, probability of not an ace, we use a bar above it for not ace, is 1 minus the probability of drawing an ace. So first we have to find what the probability of an ace is, and then subtract it from 1. Well, the probability of an ace is the number of aces over the total, right? So if you look on your sample sheet, right, if you flip it over, yeah, I did it so that all you have to do is just flip it back and forth. Now, how many aces do you have? There's 4 aces, right? Over a total of 52, right? So there's 4 over 52 minus 1. So if we simplify this, right, 4 into 52 is 13. Okay? There's 13 in each suit, and there's 4 suits. So if you divide 4 into 52, you get 13. So that's an easy way to remember. So this will be 1 minus 1 over 13. So if we change the 1 to common denominator, what would that be? What over what? We need a common denominator, right? So this will be, well, we need 13 in the denominator, right? And so 13 over 13 is 1, right? So you just change the 1 to whatever this denominator is, and now we can subtract, right? 13 minus what is what? What's 13 minus 1? 12. So our answer, and we can't simplify that any further because 13 is a prime number. So our answer, our probability is 12 over 13. Well, what is that as a decimal? 12 divided by 13, 0.92. So that means that if we drew 10 cards, we may get one of them as an ace, right? If we drew 13, 12 of them will not be an ace. Well, let's see. There's 1, 2, 3, 4, 5, 6, 7. Well, there's 1. 8, 9, 10, 11. Well, there's 2. 12, 13. Okay, so we were able to get 2 out of 13, right? So that means that on the next, if we drew 13 cards again, the chances are less likely that we'll draw any ace because we drew 2 of them this time. Well, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, there's 1. 11, 12, 13. This time we only drew 1 ace. So if we go one more time, the chances of an ace are even slimmer because our probability is 12 out of 13 that we would not get an ace. So let's try one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We didn't draw an ace this time. But considering we already drew 3 aces, right, the chances of drawing another ace on the next 13 cards is really slim. Right? So that's kind of how probability works. You may not get exactly that number, but over a long